The morphable face model is derived from a dataset of 200 colored 3D scans of faces. Individual faces are combined into a single morphable model by computing dense point-to-point correspondences to a reference face. A modified optic flow algorithm establishes 3D correspondence automatically. The morphable model combines 3D shape and texture information of all example faces into one vector space of faces. We can form arbitrary linear combinations of the examples and generate continuous transitions. Starting from the average face, individual original faces are caricatured by increasing their distance from the average. Forming the average for male and female faces separately, the difference can be added to or subtracted from an individual face to change the perceived gender. Other facial attributes, such as the fullness of a face, can be manipulated in a similar way. From a labeled set of faces, the characteristic changes are extracted automatically. In our model, they're controlled by a single parameter. Differences in facial expressions captured from another face can be mapped to any individual. We now reconstruct 3D shape and texture in order to animate a face, given only a single photograph of a person. First, we manually align the average face to the target image, roughly estimating position, size, orientation, and illumination. Then, a fully automated algorithm finds the best reconstruction of the face within the morphable model. 3D shape and texture are optimized along with parameters such as size, orientation, and color contrast. The output is a high-resolution 3D mesh of the face. It is an estimate of 3D shape and surface colors based on a single image. Additional texture extraction improves details in texture. The reconstruction can now be rendered into the image, and a whole range of facial variations can be applied. Here we simulate weight gain and weight loss. Facial expression can be post-processed in images, forcing a face to frown or to smile. From this image, we also estimated 3D shape and texture and combined the photograph with 3D computer graphics. Cast shadows of novel objects are rendered correctly into the scene. Illumination conditions can be changed, and pose can be varied to some extent. From a single black and white image, we obtain a full estimate of 3D shape. The result of the matching procedure includes an estimate of surface color, since the morphable model contains color information. Finally, we show the application of our model to a painting.